Now recording. So, how is everybody this afternoon? Surviving?
Just barely.
Just barely? Well, hey, sometimes just barely is all you can ask for, you know? So, let's make a new, create a new project right there. C# console app. Call it whatever you like. There we go. Create. It's hot in here. In this room, you're actually, you can just do the HVAC. So it's too hot in here, so I'm going to turn it off. Maybe it'll cool down. Hopefully. Because that's not the air conditioning. You know? That's a furnace, not an air conditioner. I'm pretty sure. Anyway, if it gets absolutely stifling in here and we start, keeling over from oxygen deprivation, I'll turn it back on. Anyway. So, I promised you last class that we would begin this class with a second run at the switch case. Right? So, does anybody remember from the last class what a switch case does? What is it a synonym for? Yes?
It works the same as if statements, if and else.
That's right. Specific types of if statements. In particular, if you are performing a series of equality comparisons, a switch case can be used instead of the if statements. So, for example, let's say we have a neat little program. Console.writeLine. Enter a letter grade, A to F. Then turn you off. There we go. Back in business. Don't worry, you didn't miss anything. So, string response is equal to console.readLine. So, we'll just ignore that warning for now. So, if we recall what happens when we run this, when we run it, there we go. Enter a letter grade A to F, cucumber, and the program exits. exits because we're not doing anything with it yet. So, we could write a series of if, else, if statements. Come on in. If response is equal to A, console dot write line what a clever cookie. Else if response is equal to B, console dot write line. You are meeting expectations. Good job. Else if response is equal to C, console dot write line. You could be doing better. Try improving. Period. Have you considered improvement? Else if response is equal to D, console dot write line something sarcastic to say.
Do better.
Yes, D stands for do better. There we go. And else if response is equal to F, console dot write line. Well, they're always hiring in the army. So, if we run this, why do I always have to click it twice? There we go. If we enter A, B, you are meeting expectations. Good job. Right? Whichever of these you enter, you get the stated response. In addition, we can add an else case. Else console dot write line. That's not even a proper letter. Which is what you get if you say, for example, banana. That's not even a proper letter. So, this is fine so far as it goes, but it's kind of cumbersome. Let me show you what the equivalent switch case looks like. Rather than starting it off with an if statement, we start it off with switch. We specify the thing we are switching on, response. We then indicate our cases. Case A, B, C, D, and F, and the final one, which equates to our else case, is default. you need to include break statements. More on those later. But basically, without a break statement, execution will fall through from one case to another. After that, we can put our console messages in like so. And there you have the switch case. So it's not that the switch case occupies less space in the program. It actually occupies about the same amount of space in the program. There are things you can do with the switch case that you can't do with if-else-if instructions. At least, well, like you can, but it's more difficult. So, actually, this kind of touches on another point which may shock and astonish you as people learning programming for the first time. There's a very famous result early on in the study of computation called Turing equivalence. This is also sometimes called the Church-Turing thesis. So, does anybody know who Alan Turing is? Not a single one of you. Alan Turing is to computation as Isaac Newton is to physics. He invented a great proportion of the science of computation. He's a very, very important figure. They did a movie about him a few years ago, which I believe was called The Imitation Game. So if you're interested in a bioflick on Alan Turing, who is the grandfather of all modern computation, I recommend checking it out. But anyway, the Church-Turing thesis states that if a language is so-called Turing complete, that means that it can express any program expressible in any other Turing complete language. So, what that means is that essentially, if you have two programming languages, so long as they have some common constructions, any program you write in one can be written in the other. The only question is, how difficult is it to do so? Excellent example. The Pokemon games for the Game Boy, right? The old ones, red and blue, right? These programs were written essentially in assembly code, right? Has anybody seen that thing where like they get Pokemon red and blue operating in Minecraft? You guys seen that? So the redstone circuit system in Minecraft is Turing complete, believe it or not. So any program that you can write using a Turing complete language could in theory be done in Minecraft in redstone. The only question is, how long would it take you? And like, do you have to write like a bot to lay out redstone circuits inside of a Minecraft world or something, right? that's how I think they do it. I don't think it's just like one guy, you know, mining it all and laying it out. They probably have like a mod for it or something that allows them to write the circuits in. Yes?
There's a mod that shows you what blocks need to be placed, and you like, it's like a blueprint, and you just walk around and place them, just gonna mess it up.
Yeah, and like if you're gonna go to that trouble, why not just, you know, do it yourself? Or just have the bot lay it for you, right?
You could do that too.
Yeah, but
I also have another question.
sure. You can ask your question while I'm pulling up a picture of let's see, one second. Pokemon Red in Minecraft. It's like, there it is. Like obviously that's not a Minecraft world as generated, obviously, right? But yeah, there you go. There's Pokemon Red as implemented in Minecraft in Redstone. What's your question?
How do you go, there's like an indentation question, and so you did like all these cases, but how do you get it back up, like on the same line?
Oh, just type case, and then when you press enter again, after you've completed that, it should auto-complete its correct indentation level. There you go. Actually, it's the colon that does that. So, basically, if you wanted the minimal set in a programming language like C#, if you want the minimal set of instructions from which you can write all programs, it would be, you need to be able to read variables, you need to be able to write variables, you need an if statement, and you need a while loop. And if you have that, you can implement literally anything. Everything after that is convenience, right? So basically, the course as we've learned it up to like the end of last lesson, excluding all of the Unity stuff, you guys can now write any program. Literally any program. The only question is how hard is it to do so, right? So switch cases are useful for some things that you can't use otherwise. But first, let's test it to see that it works. Enter a letter grade. How about B? There to go. It works as it did before. Ooh, here's an idea. Case E. Ordering grades off the secret menu I see. There you go. So, here's an interesting thing. In this scenario, if someone gets an A, it is also true that they are meeting expectations. So, we can remove the break statement like that. Uh-oh. Okay, whoops. Never mind, can't do that in C#. You can do that in Java, but not in C#. So in Java, you can let execution fall through, but here you require a break statement after each and every one, which kind of begs the question why you would even need them explicitly in the language then, but okay. You've disappointed me, C#. But anyway, any questions about switch statements? Everybody feel you, yes?
Where's the, how do you put the one in the if statement if they input something that is none of those?
How can you input the one?
Sorry, like in your if statements, it was if they input like none of these options, A through F.
Oh, else. Just else with no condition. Like that. Else with no condition catches all of the cases that weren't satisfied by the above. Any other questions? Good. Excellent. Okay. So now, let's talk functions. Functions and methods. So, the story of the history of computation as it has developed since the old days of punch cards and mainframes is one of abstraction methods, abstraction mechanisms. It used to be, back in the day, that you had to punch out the binary codes for the instructions that you wanted to use on a punch card. Later, when computers started having displays, binary instructions were substituted for instructions in words. This was an abstraction from the original binary. It allowed us poor mortal human beings to work with the data more efficiently. As things progressed, it turned out that certain common assembly code patterns could be collected up and called different things, and that it was faster and more efficient to program in these new constructs than the original assembly code. This was the advent of what are called fourth generation programming languages, such as the C programming language, from which C# is derived. So the code as you see it here is an abstraction from assembly code. One of the things that makes a language powerful is the abstraction mechanisms that it gives you the program. One of the most basic abstraction mechanisms that you can have in a programming language is the ability to take blocks of code, give them a label, give them a name, and then refer to them by name elsewhere in the code. In the old days, they used to call these subroutines. These days, we call them either functions or methods, sometimes interchangeably. When I say function, I mean method. When I say method, I mean function. They're the same thing. The only difference is that methods are attached to classes. Technically, functions are not attached to classes. But if you're programming in an object-oriented language, pretty much all function, anything you think is a function, is attached to one class or another. So technically, all functions are methods, as kind of a general rule in object-oriented languages. It doesn't change the fact that the fundamental structure is exactly the same between methods and functions. So, we know what methods are. We've worked with some methods in Unity already. Can anybody tell me what methods we've used in Unity already? Anybody? Yes? Update, yes. Very important one, yes. The update method, which is provided by default inside of your boilerplate code for a newly created C# script in Unity. What's the other one? Start, yes. Very good. So I'm glad you picked those two, because those are methods which we have defined by filling in. We have used methods lots of times in Unity. Debug.drawArray is a method, right? What was the other one? Physics.raycast, that's another method. So because we have methods for these operations, we don't have to go find the source code that implements those and copy paste it into our code. Right? This means consider the possibility that at some point in some future version of Unity, the code which performs a raycast is updated. Right? They update Unity, they do raycasting slightly faster, something like that. If the way you implemented raycasting was that you went to their source code, copied their code into yours, are you going to get the update when they update it? We have person A and person B. Person A has some code, say a.cs, right? Person B would like to use person A's code. Person B acquires the code through Control C, Control V, right? Just goes in, finds the source code, copies it, pastes it into their own work, right? So now we've got a file here, b.cs, containing both B and A, something like that, right? Let's say that person A improves a.cs. Right? Does this code here get the update?
I would assume you would.
No. You would be relying on B to watch the state of changes on a.cs, and when an improvement is made, copying and pasting again. All right? That's a bad scenario. You don't want this. Okay? Consider the following alternative scenario. Let's say that person A and person B, again, we have a.cs. Let's say that rather than getting the code via Control V, Control C, person B writes the code in such a way to reference a.cs. Right? That is to say, B calls a function or method from, right? B calls a method or function from A, right? That means that whenever b.cs is executed, it goes out and gets the latest copy of A. So, if A is improved, any improvements are automatically applied to B, as B has not taken a static copy of the source code at some point in time and saying, this is where you find the code I want. Right? So, B gets A's improvements. Does that make sense? This is a very important concept in software engineering called modularity, right? So, because A was used as a module, something that clicks into B, instead of just taking the source code and pasting it all into B as a monolithic thing, the module itself can be dealt with separately as a small little instance, and you don't have to, you save yourself a ton of work. Does that make sense? Here's another scenario for you, and this one, just one person, right? Let's say that in some source code file, right, we have our lines of code, right? And let's say, just for the sake of argument, we have several lines of code. I know these don't look the same, but just trust me. Let's say that all of these three are identical. Right? We have blocks of identical code inside of our larger piece of code. Right? The thing that every programmer really like a brain itches until you do it, right? Is to take all of these out, write it once at the top, say it's a function, and then, instead of writing all that code out each time, substitute it for the function call. Right? Here, you get the same benefit as here. Let's say, just for the sake of argument, these identical lines of code, which you probably produced by copying and pasting, contain a bug. Right? Let's say that there's a nasty little bug. Hello. Let's say that there's a nasty little bug hanging out over here. Maybe there's the same, and since the lines are exactly the same bug will be in the same spot every time those lines are used. Here's the problem though, right? Source code files can be hundreds or thousands of lines long. You are relying on your own brain to remember where all of those pieces of identical code lay. Right? This is dangerous. It's dangerous to rely on yourself to that extent. Because if you're trying to fix a bug in duplicated code like that, you are going to miss some. Right? You will miss some of the bugs. You will maybe squash that one and that one, but this one will persist unbeknownst to you. And it will look like you fixed the bug most of the time. But every once in a while, maybe every 20 or 30th time you run the code, that bug's back again. You're like, I thought I fixed that bug. But you didn't, because you didn't fix it everywhere. Compare that to doing this. The bug is in one spot, you fix it in one spot, and now it's fixed everywhere, forever, eternally. Everyone goes home happy. Does that make sense? That's another good reason to use modularity, using methods and functions. So that's why. Alright? So, let us review syntax. So, the way that you create a method in C# is by specifying what are the inputs, what is the output, and what is the function's name. You can also set them as public or private, but let's not worry about that for now. So let's say I had an int add3 method. There we go. Taking 3 integers in. So, this is a method which takes 3 inputs and calculates the arithmetic sum and outputs the result. Alright? So, the anatomy of the function. This right here, this data type, indicates the return type of the method. Because we are adding 3 integers together, we expect the output to always be an integer. Functions in C# may only return one type. If it returns a string, it better not be returning a Boolean. Right? Because then it won't compile. Next, this is a decision. The function name is something that you decide on yourself. You should pick something that is informative and makes sense and describes what the function is meant to do. Right? So in this case, we are adding 3 numbers, adding 3 integers, so I have named it add3. Make sense? Next, we have the list of arguments. These are called arguments or parameters. Argument, parameter, or input. Right? You may notice that these look quite a lot like variable declarations. That is essentially how they function. When we declare int x, int y, and int z, we are preparing for ourselves 3 variables, x, y, and z, all of type integer, that are bound to the function. They do not exist outside of the function. They are just for use within the function itself. Does that make sense? Any questions so far? Yes.
Why is the int this start? Is that because the output is an integer?
Yes. The int here indicates the return type. So it's the type of the output. Yes. Yes.
If we were like to declare the variables of the integer x, integer y, integer z, do we do it outside of the function or inside the function?
I'll show you how to use it once I finish the current thing. Okay. So once you have your inputs You then open a code block using curly braces, the same way you do for an if statement. In here, you put as much code as is necessary to calculate whatever you're trying to calculate. In this case, it's very simple. We are just calculating the sum of x, y, and z, and we're using this funny thing, return. Return specifies the value to be returned from the function. So it specifies the value which will be the output of the function. When I say it returns x plus y plus z, it first calculates the value of this expression, then it sets that as the output of the function. Does that make sense? So far, so good? So, to use the function, and I'm just putting this inside of a console write line so that we, well, now I'll declare a separate period, separate. Int f is equal to add 3, 5, 7, and 2. This is a function call. We are calling the function. We are invoking the function. We are running the function. Right? When execution reaches this expression, it takes all of these provided arguments and it assigns them to the variables specified in the input. So in this case, x gets the value of 5, y gets the value of 7, z gets the value of 2. Then it performs the function, returns the output, and replaces the function call with its outputted result in line. So this add 3 yada yada gets replaced with whatever the result of 5 plus 7 plus 2 is, which is
14.
very good, quick maths. So then this expression gets rewritten to int f is equal to 14. So f gets the value of 14. As we see when we run it. There we go. 14. Does that make sense? Any questions about that? There are lots of other like silly little rules to do with it, but these are the basics. So, we don't have much time left in class, but with the time that we do have, try getting that to work if you haven't already, and if not, try writing me a function which calculates the Pythagorean theorem, the hypotenuse of a triangle where the two side lengths are specified. That's a good function. I suppose it would be A, B, and C, wouldn't it? You'll want double. Yeah. The number of Pythagorean triangles, which like come out to like perfect integers when you calculate that, is very small. But here's one of them. That's like one of the, there are a few, like integer value type, Pythagorean triangles, but there aren't very many of them. So the data type you should be using is double or float.
I thought I could double it. Double.
Yeah, just double.
Double.
Yes, it stands for double precision floating point number. Did you get it? Cool. Yes. So, the first line of the function will always only specify the, what the inputs should be. Yeah, so don't do any math. Oh, yeah. Yeah, yeah, that's the other thing is we want doubles everywhere. So, that's pretty much it for class. Thank you for your time and attention today, folks. Friday, we will be doing lab 2, so come prepared. As review, please study the things that we did in class. Yeah. I'll see if I can get the lecture video for this one published a little bit early so that you guys actually have time. It defaults to scheduling them at like midnight the day you upload them, which is what I often do. But who knows? If I stop talking and just go back to my office, I might just be able to do it right now. So, all right, you are dismissed. Is this another situation where you have the next class in this room too?
No.
No. Okay.
I don't know, square root. So. I was just asking.